All right, in this video, we're going to continue with this idea of point of inflection and concavity. We're going to take a look at a slightly more difficult function. And again, the difficulty in this does not lie necessarily in the test for concavity and point of inflection. It's simply it's really nothing more than taking the derivative and then taking the second derivative are just a bit more challenging. Okay, so let's go ahead and take a look at this. Our first derivative, we got to use the product rule and a combination of the product rule and the chain rule. So we take the product rule, which is derivative of the first, which is 1 times the second. So we get root x plus 3 plus the derivative of the second, which is, if you check me, it's going to be 1 over 2 root x plus 3 times the derivative of what's inside, which is 1, times the first, which is x. And so we're going to have a 1x on top. Okay. And so that's one way to do that. And now I think what I'm going to do, because I've done this problem like 67 times, and my videos haven't turned out, I'm going to go ahead and get a common denominator and kind of combine these two. Okay, that's going to help me in the end, at least I think. And so the common denominator is going to be simply 2 times the square root of x plus 3. And now that will give me 2 times x plus 3 on top, and so that's going to be 2x plus 6 plus x, which is 3x plus 6. Okay, so that's going to be my first derivative. Now let's go ahead and take the second derivative. We take this mighty second derivative here, and we're going to take, you can use again, we're going to use the quotient rule this time, but we have to use it in conjunction with the chain rule because of the root. So we take the derivative of the top, which is 3, times the bottom, which is 2 root x plus 3, minus the derivative of the bottom. Ooh, this is going to be nasty. The derivative of the bottom is going to be 2 over 2 root x plus 3 times the top, 3x plus 6. Okay. Now, the 2 root x plus 3 came from the fact that this is actually raised to the 1/2, and so if you use your power rule, you get a negative 1/2 as the exponent. So the derivative of this was derivative of the first times the second. That's where this part came in, minus the derivative of derivative of the top times the bottom, minus the derivative of the bottom times the top, all over the bottom squared, which is going to be 4 times x plus 3, which is going to be 4x plus 12. And now we need to do some playing here in order to get this thing rendered down to something usable. So again, we can go ahead and get common denominator, and I think that's what I'm going to do here. And so my common denominator will be 2 root x plus 3, and this is just for the top. So I have 2 root x plus 3 times 2 root x plus 3 is going to give me 4 x plus 12. So I have 3 times 4x plus 12 minus 2 3x plus 6 all over 2 root x plus 3, all of that over 4x plus 12. This is the particularly nasty part. So when we do this, we notice that we have, if we kind of finish this up, by the way, this is the second derivative, is equal to that junk. And so if we clean up the top a little bit, we get 12x minus 6x for 6x, and we get 36 minus 12, which is plus 24 over 2 root x plus 3, all over 4x plus 12. There we go. So now we can invert and multiply, so the 4x plus 12 comes down on the bottom. Again, this is not really going to help us all that much, but we can clean it up a little bit. And so we have, if we invert and multiply, taking care of that. We have x, or 6x plus 24 all over 2 root x plus 3, 4x plus 12. Canceling out 2's in both the top and the bottom will lead us to 3 here and 12 here. And so finally, after what seems like an eternity, we have 3x plus 12 on top. Underneath, we have root x plus 3 times 4x plus 12. And that's it. We can't really factor out anything else. We may be able to, but we might be able to, that would probably turn into something very nasty. And the reason I say that is, remember, all we got to test is whether the second derivative is positive, negative, or 0. And so right now, let's take a look at this. What numbers can we input for this? Where is this defined? We can't have 0 on the bottom. And we also cannot have a negative under the root because right now we know how to do calculus, but not complex calculus. And so in this case, we are limiting ourselves from -3 to infinity. So if we get numbers outside of this interval, we don't have to worry about them. Let's go ahead and set our second derivative equal to 0. And so now 0 is equal to 3x plus 12 all over root x plus 3 times 4x plus 12. In order for that to be true, this means that 3x plus 12 is equal to 0 or x is equal to -4. Oh, darn. Well, that falls outside of our interval here, so we don't have to worry about it. This has no point of inflection. There is no change in concavity, at least not in the defined sense. And so all we have to do is we have to just test some random number in here, and I'm going to randomize it and call it 0 because 0 is a nice easy number. And so I'm going to take and check the concavity of it by simply taking x is equal to 0. When x is equal to 0, then our top is 12. Our bottom is √3 times 12. And so we have positive over positive, which is greater than 0. That's all we had to test. I don't care what this actually equals, 1 over √3. That doesn't matter to me at all. I just want to know if it's positive, and it is. And so this is concave up. Remember, we're just checking the sign. We don't need to know what the actual number is, and that can save you a lot of time. Okay, so let's check we have no point of inflection. Okay, so we don't have any of those. We are concave up from -3 to infinity. And so this whole thing, no matter what, is going to be concave up. So what does it look like? If you graph it on your calculator, this original function is probably going to start right about here. And it's just kind of wander slightly upwards. Okay, this is going to behave in the family of x to the 3 halves. That's going to be the family of the functions. And so we have a point where it just doesn't exist anymore past that point. And it's just going to kind of wander upward, kind of like a parabola. And that's why it's concave up the whole time. All right, again, just some really simple steps. If you're testing for concavity, all you're simply going to do is take the first derivative, then the second derivative, set the second derivative equal to 0, solve for all the points of inflection. Then you're going to test on either side of each of those points. So if you had 3 points of inflection, you're going to have 4 intervals to test. Once you've tested all those, then each one will tell you whether or not each candidate is a point of inflection and where the concavity lies. And remember, only testing for sign. You don't have to get a number.